And let's just backtrack a bit and see, for people that don't know you, who are Luka?
So,
who is Luka?
I'm the co-founder and the CEO of Peltarion, Swedish AI company that creates a platform that makes it possible for non-data scientists and non-AI experts to build advanced AI systems and put them in production.
And I think we can speak more about Peltarion later and the vision and the reason for you starting the company. But perhaps a bit more about you as a person. You went to KTH, right, before?
So I studied electrical engineering together with Måns, my co-founder. And we were originally drinking buddies rather than professional buddies.
As everyone in university, I guess.
So, then towards like it was the third or fourth year, we started getting interested in AI. Actually, my first encounter with AI, with neural nets, was when I was in high school. And I had this like Windows neural network simulator, which was
So that's a Windows operating system, you mean? Some kind of simulator on it?
It's a simulator on it. And it looked like it was like a window, and on it had a lot of boxes, like text boxes, and there were some random numbers in it. And I didn't understand anything of it. So that was my first contact with neural networks. Then I deviated a bit, and for like my what's it called, exam project in high school,
thesis project.
Thesis project in high school, I did a chatbot.
Really?
Yeah.
That's an interesting story by itself. But okay.
So
what year is this? You remember?
This must have been 97.
Early chatbot.
Yeah, and basically what it did, it had a library of answers that were keyword triggered, and then it had a grammar engine that tried to make something sensible out of the sort of sentence when it didn't occur in the sort of keyword hit list.
It sounds unfortunately how chatbots work still today in some way.
Yes.
Okay, cool. So was it during your studies that you started to have a passion for neural networks? I know that you had a passion for that long before even deep learning happened.
Yes. So I think it was like not in the last year, but like towards the end of the education, I had a couple of AI courses, and both me and Måns were fascinated by the concept of the computer programming itself. Right. So we tried a bunch of things. Neural nets was one. Another was genetic algorithms in various fashions. So we had one of the naive ideas that we had was like, hey, evolution can build these really awesome things. Why can't we just generate the programs, generate it sort of bit by bit? Of course, the computing power wasn't anywhere near that, and still isn't anywhere near to be able to do that. But then we sort of got more into neural nets, and we started the company while we were still at university, and sort of made our product as part of our thesis project.
All right. Okay, so your thesis project was about some kind of tooling for
So
AI,
it was, I think the title was Neural Network Applications in Classical Mechanics, but that was just a cover so that we could in peace sit and develop our...
And what was your initial business or product idea at that point in time?
So what we saw was that neural networks are awesome, but it seemed to be confined just to academia. And those people in academia, they seem to enjoy it a lot, that this was this esoteric secret science that people were doing. So we thought like we should simplify this. We should make this much more user-friendly so that it could be applied to real-world problems. So in many ways, what we did back then is the first iteration of what we are doing now. Now, of course, technology has changed, user base has changed, and so on. So there are differences. But the core idea of having a simple user interface to be able to build neural networks and deploy them.
That's the basic first principle idea here.
Mm-hmm. And then I would say possibly sort of the strongest are sort of where we invest most time there was building this big pre-processing and visualization engine.
So you started to build some kind of product or tooling or
So it
development environment, or how would you call it?
We call it a development environment.
Yeah.
It was sort of inspired by Microsoft Visual Studio, but it was fully graphical. We could import your data, visualize it in various ways, then build a model, train it, and then put it into production and analyze and things like that.
And that was like a desktop application at that point?
Yes, that was a Windows-based desktop applications. This was before GPUs and so.
So what are we talking here? When did you go? When did you graduate?
2004.
2004.
Right.
What were you doing 2004?
My PhD, I guess.
You were in PhD, and I was right about moving to Australia to work and surf.
Yeah,
cool.
Cool. That's a long time ago, but still, yeah.
Not that long, but it feels a long time ago.
Yeah.
Oh, actually, it is a long time ago. 16 years.
Yeah, but I remember the first time I saw Synapse, which became the name, I guess, at a later point in time. How did the name come about, so to speak, for that?
I think I saw a movie with Tim Burton that had this super conspiration thing that was this software that's going to take over the world that was called Synapse. I think the original, the sort of first name that we had before release was iStudio, like Intelligent Studio, but I was like,
cheesy.
Cheesy, yeah.
So
Synapse is cool.
Yeah,
not
I
bad,
think so
not
too.
bad.
There's another Swedish company called that, I think. Now.
Is it now? Of course it is.
There's also Microsoft Database that I just call it. Very confusing.
Very confusing.
True. Okay, so you started to build this tool, and if you were to just very, very briefly describe what was the functionality of Synapse, how would you describe it?
So you could import data from a number of sources. It was built entirely plugin based.
Yeah.
So every part of it you could add to by just writing a new plugin. So you would import your data. You had a number of formats, and then you had the whole pipeline for pre-processing and visualization and data mining. So you could add filters and pre-process your data, and then you got your data to the model builder part of the app, where you could construct a neural net.
And you use the term like filters, etc. Was it intentionally like from Photoshop kind of terminology kind of thing? Or?
Exactly. So it was, we basically got the idea from Photoshop to have non-destructive filtering where you do modifications to the data, either on a sample basis or a feature basis. And that you could basically rearrange them and remove without touching the data. And then when you ultimately sort of applied it, when it went into the model, and also then when you deployed the model, then you will get the filter stack there deployed.
Right. So it's coupled with the model in some way.
Yeah.
And when did you pick up sort of your programming skill or software skills? Is that at university, or is it something you've been doing also? Hacking
much earlier.
Yeah, hacker by birth.
Never hacker fully. Never sort of the demos scene and so on. It was more on a. So I think my first software that I remember that I wrote, that I was perhaps 10, 11 years old, and I had this. Me and my friend, we had the same type of parrot as a pet. And I wrote some software that was basically an instruction book for keeping the parrots and a log that you could do things. So
what are we talking now? Commodore 64?
So it was in parallel. So Commodore 64 was one, and then this was on some like QBasic on 286 PC.
PC,
yeah.
Because I think this is pretty cool. I mean, like... I have three kids, like 14, 12, and 10. And I think we have I've picked up that my middle kid I think he has an aptitude and interest for engineering and software and stuff like that. But right now he gets sort of completely bogged down in playing Minecraft. And we are trying to sort of get him inspired, why don't you try write some code, or why don't you go to these classes? So he went to one of these courses, something like Höstlovs education at Tekniska Museet. And I think he kind of loved it, but he doesn't sort of get into it, right? Mm-hmm. So we try to give him a computer. What was the triggering fact, sort of getting mesmerized by computing or writing software? Not all kids do that. More kids should do it, I guess.
I don't remember, but
Fascinating.
what I sort of, for me, what coding is and what I'm missing today when I don't is the creativity of it. That you can create something, you can see the results rather immediately. Cool. So it's for me, it's always been like a creative kick.
Yeah, very cool.
And then Synapse, you could import your data, you could do the filtering, some kind of preprocessing, and you could train some models. And I guess that was not only neural networks, right? You did support some other stuff?
We also had support for trees, also some more obscure things like fuzzy logic. And it's all a tree graph anyway. So yeah, and things that are not, which I'm just basically waiting for it to come in new editions, but like self-organizing maps, neural gases, and things like that.
Yeah, and I know you're a bit humble here, so you don't want to say all the people that used it, but people can Google for this later. But it was a lot of companies that made use of it, and a lot of research papers that were written making use of Synapse, right, during that time. Yeah. And a lot of like NASA and Tesla and whatnot that actually made use of that in some way, right?
Yes. It was interesting. We were completely flying blind. So our sort of whole go-to-market idea was, yeah, the internet is big. So if we put out some ads, I mean, the internet is so huge that's like people will come and this will become a global big giant. And then what we weren't aware of was that we were in this period today known as the AI winter, or the second day.
No one told you about the AI winter.
No. And when we realized that, then we tried to cover things up a bit. So we never said, we censored away neural nets and we called it adaptive systems and things like that.
Oh, so it was uncool.
Yeah, it was very uncool.
Yeah. That's funny. You were riding the opposite hype train. I love it.
No, I remember when this must have been like in 2006 or 2007. We were at one of these conferences that are now huge.
NIPS, Ishka.
It could have been NIPS, or was it ICA? So one of the sort of neural network specific conferences, which was like amazing for like meeting people who knew what backpropagation was. Like, it was like, whoa, like this tiny.
Yeah, sorry. But then the years went on, and you worked for that for some time. But then something happened in 2015, 16 or something. Right?
So basically, I would say what made this work? What made this work commercially? It's like, okay, we sold these licenses over the internet, and in the end, we did have some 300 customers and sort of 10,000 users overall. But it alone, especially in the early days, would have barely paid for me and Måns for our salaries. But what made it possible is that we worked with some companies. One of the early things that we did was a house prediction model. So this company that back then had the monopoly in Sweden, so all of the banks use them for doing house valuation. So when you take out the loan for a house, then they want to know if it's really valuable or not. Yeah. And basically, what they had a model in place that was like built on theory rather than on data. And they were like, they gave a valuation, and then there was a confidence interval that they got. And then the first thing we did was measure it and saw like, no, you're giving it out with a 40% confidence interval. So there's a larger chance of the prediction being outside of the range than inside of the range. So we built a prediction system there, and also, there we learned a lot on sort of putting stuff into production and the importance of the things there. But that sort of kick-started us.
Yeah.
Sort of,
and just to explain from a more techie point of view, how do you predict the value of a house? What type of data do you use, and type of model were used, etc.? So
this is pre-deep learning, so it's still neural net. So it's a feed-forward backprop neural net. In fact, it was a construction, the best models that we have that Måns invented, that was called fully forward connected perceptron array. I remember it.
Awesome. I mean, like you need to get extra points for cool names.
Yes,
right?
yes. So
is that an acronym now as well?
FFPCG. TCN. I forgot that. We always call it the acronym, but apparently I could just remember the full name now.
That's fine.
So, but it was basically a network. It was 6 or 7 layers deep, where each layer had a lateral connection to the next layer and to the last layer.
Skip connection, basically.
Yeah, or was it to each layer? It was fully forward connected. Then it's probably that each layer had to all of the other layers.
Okay, understand. Okay, cool.
And so that was the sort of the basic model, but feed forward neural net.
And if you take it in layman's terms, so I can follow, like what's the input data that you know, and what is the prediction? So
basically, you want to get a lot of inputs, like what's the area of the house, how big is the yard, and data like that, and the output is the price. Yeah. So what did we use for input? So we basically in Sweden there's Lantmäteriet that has a large database. So the national survey agency.
Yeah, with all the different lots.
Yes, exactly.
In all Sweden.
So you could get some basic information about the house from there.
Yeah.
But then the magic happens when you have the coordinate of the house, because then you can tie it to geographic neighborhood. So we had like distance to Systembolaget, how many Systembolaget.
That's an important data point to have.
that was the driving.
So loads of points of interest. And you know what the sort of most important, by far the most important and predictive.
Okay, no, I don't. Okay,
election data.
Election.
Oh,
yes.
Really? How people in that area
how people
voted?
in that voting district voted? Yes.
Oh, that's kind of interesting.
As a good coefficient for determining.
Yes. And we learned there also, since we got also the demographic data from SCB and so on. It was you could see very interesting things. We saw, for instance, back then, I don't know if that probably doesn't correlate now, but Sverigedemokraterna in the south had the exact same demographic properties as Vänsterpartiet in the north.
Don't tell that to people.
With very high statistical and mathematical precision, you guys are the same.
And the strongest predictor of a neighborhood going to hell and prices going down was the amount of Kristdemokrater in the region.
This is what data-driven means.
Yes. But it was funny because we got pretty free hands to put this into production, and when we did, so the result was super good. But then they started getting questions like, "What data are you using?" And then when the sort of oh crap, we have to go and tell them that we use voting data. Then it was but of course it's aggregated. It's on a district level.
So even with today's GDPR problems, it still would be okay.
Yeah,
I guess,
so it's 1,000 people in one voting district.
Yeah, but it's interesting that how to determine the feature that really matters.
Yeah. Plus, I mean, there's obviously, and I usually go on about this, and we already did then, is that there is a massive risk with these kind of systems. I mean, it's super tempting that you get these fantastic results, but basically what you're doing is that you're reinforcing what has been rather than what you want the society to be.
That's an ethical topic right here.
Absolutely.
Cool. So you had a system; it could basically predict the value of a house in a better way than before, and then I guess a lot of banks were basically starting to make use of it as well. Right?
Yes. So it's, as far as I know, it's still in production, and the banks use it. They tend to be slow at shifting things out.
Well, they got your system in, so that's a good thing.
But we were really, really, really terrible at business back then. So this was like we did it on a consulting basis. With that we get to keep all of the source code as well. But basically they were able then to run it for at least 10 years without paying us anything.
Oops.
It's a bit sad. Cool. Well, that was some work you did, and then it turned into this thing in 2015 and 16. What happened then? So
basically around 2000... if I back down to 2008, 2009, so GPUs were making an entrance. It was very clear, like, okay, wow, this is really cool. I can do these calculations very fast. So let's add GPU support. And we did, but the problem was that it was so early that the compute framework, CUDA for GPUs, was evolving like on a weekly basis, and we had no chance of maintaining it.
And for people that don't know, this is before TensorFlow even existed, so to speak,
yes,
at least publicly.
And then around sort of 2012, 13, 14, 15, sort of the market was taking off. Our software was getting outdated as deep learning was taking center stage. And we had the choice of basically, should we grow organically with our customers, or should we take an external investment? And it sort of came to its edge where we had a project together with SMHI, the meteorological agency. And basically the project was about improving wind power forecast.
Wind turbines. Basically.
Wind turbines, yes. Because the models that are out there are, tomorrow the weather will be like yesterday. That was a sort of
a good baseline to have.
So we started building a model for that and got some result, and then we realized the weather model that SMHI uses, that's a very, that's a finite element method based simulation that's built on a few very simple mathematical equations that may not always hold up to reality. So we got a bunch of satellite data, and SMHI has a data set called Mesan that doesn't predict the weather, but shows what was the weather an hour ago. And you get everything, you get like a map with temperatures, wind directions, humidity, and things like that. So we built a system that to try to predict the weather 48 hours ahead, and it worked really well. And the big thing here wasn't the improvement in accuracy, it was like the improvement in cost. Because we could do in milliseconds what took many hours on a supercomputer. We could do it on a cheap computer.
Yeah, that's another one of the most cool projects I think that Peltarion has, about being able to do weather forecasting basically in a really efficient and fast and cheap way as well. Yeah, really cool stuff. So predicting value of houses and doing weather forecasting, and what can you not, dancing, and a lot of cool stuff.
And what was the sort of shift to what Peltarion is today? Or like, what's
so basically at that point, I never finished
exactly
the story. Yeah, so it was basically we had this weather model that was like, okay, this seems great. How do you commercialize it? And then we met with EQT Ventures, who became our first investor. And met with a team there that were basically, they weren't really, their interest in the meeting was that they had a AI project of their own called Motherbrain that tried to predict who they should invest in. But then they looked at what we've done, and then they said, you idiots, you shouldn't be like looking how to commercialize a weather model. It's your platform. You should. That's the big thing. You should continue doing that, and don't get sidetracked on these sort of vertical implementations. But you should do it properly financed and with modern technology. And we were super happy that it was somebody who really understood. So that was the.
So in a way, they were part of shaping the end idea where we are going now, like in these conversations.
They were the one. They reinforced that the sort of core idea that we had there, that there was something.
Actually, even the first idea.
Yeah. Because what the current platform is a modern version of Synapse. It's cloud based. You have GPUs. It's there's come new things like transfer learning and things like that. But at the core, a one-stop stop where you can import your data, look at it, build your models, train them, deploy them. Sort of that thing is the same, but a couple of order of magnitude more complicated because it's cloud-based now. So it's not just somebody running a desktop software on your own computer, but it's many users simultaneously distributed in the cloud. So.
Cool. So you got some funding from EQT, and then you started to grow from being a 2 people founder only kind of company to how many are we today? Would you say?
A bit, slightly under 100.
Yeah. And we got there was some additional funding, right, as well after EQT.
Yes. So after EQT, the Wallenbergs came in.
Yeah.
And this was a part of a larger thing where we basically what we're seeing then, which was a couple of years ago, but still seeing today, is that the US and China are really leading the AI race,
Right.
and that we have to do something to be competitive. And this is not a zero-sum game. I'm not saying that because we are losing out because China is good. We're not. But we have to have something to contribute as well, since everything is based on trade.